Good afternoon, everyone. Good afternoon to those who are here on site, but also to those who are following us from home or from the office, benefiting from the streaming of this session. So my name is Philippe Jacques. I'm the Managing Director of EMIRI, the Energy Materials Industrial Research Initiative. I'm also acting as Secretary General for BEPA, the Batteries European Partnership Association, which is partnering with the Commission in the BAT4EU partnership on batteries. And I'm coordinating the currently ongoing Advanced Materials Initiative for 2030, which is really aiming at setting up a new partnership on advanced materials. So what we would like to discuss today, you know, the recent crisis that we faced with the COVID, with the war in Ukraine, really highlighted the fragility of our supply chains. And at the same time, the twin green and digital transition require enormous amount of materials on one side, but also this transition requires a lot of investment in new clean technologies. And these, both the materials and these technologies come mostly from abroad. So we really have an issue in Europe about our resilience, about our sovereignty. So the question is, how are we going to avoid replacing the fossil fuel dependency we were suffering in the past by another one on critical raw materials or on technologies? So for sure, advanced materials will not solve it all, but it's probably part of the solution. And that's really what we would like to discuss in this session, with a particular focus on the substitution of critical raw materials on one side, but also on how these advanced materials can really improve the performances of the clean technologies and also the competitiveness of our European industry. So we are going to have first general introduction by the different panelists. Then we will go into a more interactive discussion, and hopefully we will still save some time also for an open question and answer with the audience, both here on site and online also. So we will be using Slido. I guess you know, for those who are attending the previous sessions, that you have to just connect to Slido using this code EUID 2023 and make sure that you choose room 4 so that you really put your question in the appropriate place. Okay, so let me introduce our first speaker, Theodor Kussow. Theodor is a project officer at the European Commission Joint Research Center. He is active mainly in R&I analysis, strategic energy technologies, and innovative business development, but also on materials for strategic technologies and sectors. And in that regard, he has been one of the authors of this wonderful foresight study that was released a few months ago, and that was really supporting the Critical Raw Material Act proposal from the Commission. So Theodor, can you please, in 5 minutes, tell us more about what is really the ambition of this Critical Raw Material Act, but also of the other one that was also announced on the same day, which is this Net Zero Industry Act, which is very complementary, if I'm right. Please.
Thank you very much. Hello, everybody. So, as you've heard, I'm part of the European Commission's Joint Research Center, and I'm part of 2 teams, so you'd have the pleasure to hear about both of them. So one of them deals with competitiveness and research and innovation, and this is the team that was working behind the scene, let's say, about the Net Zero Industry Act. And the second team is the one dealing with critical raw materials and supply chains. And as the name goes, this is the one that did the foresight study on the Critical Raw Materials Act, as well as some work on the consultations and the preparatory work for the policy. So as you know, each one of these policies is relatively short, but then it has a huge amount of other documents supporting it and data to support these claims and these proposals there. So to get directly to the point, the Net Zero Industry Act is proposal to scale up European manufacturing capacity for strategic technologies. And this is mainly focused at the later stages of the supply chain, while the Critical Raw Materials Act is focused mainly with the sourcing and the recycling and everything to do with the raw materials, again, for these strategic technologies. Both of them are dealing mainly with energy technologies. So this is also the expertise in my team, in my sector. But of course, they're having some other ones, such as fuels and transportation and so on, which are again relevant to the energy transition. But I'll mention mainly the ones on energy generation. So for ENZIA, the main technologies that are listed are solar, wind, batteries, heat pumps, electrolyzers, and as you already noticed, these things, they don't come from a pipeline. So this is something that we have as a motto in the materials team, that the energy transition is a materials transition. So when we're phasing out fossil fuels, or when we're changing the system, we need a lot of these materials. And these materials, as Philip correctly said, they're coming from external countries, external to the EU, so third countries. Some of the targets that the Critical Raw Materials puts is that 65% of these materials, for each one of them, should not be only from one country. So the goal is to limit this, so to diversify these supply chains for these materials. Also about recycling and about investments in research and innovation for like substitution of some of these materials. There are further targets and stimulus for these technologies. Then when it comes to the data of our report, we have made some big calculations, and we were a bit scared in the beginning, to be honest, because when we saw the target for solar and wind, what needs to be achieved not in 2030 as initially planned, but way earlier, the numbers were really striking. We needed between 1.5 and 2 times more lithium, silicon than what we have now, like in 2020. Like we would need double the amount for 2050 to reach the targets, to reach the 600 gigawatts of solar PV. And similar for wind, the neodymium would increase also almost 5 times. So these numbers are striking, but it's not impossible to reach it. So there are things to be done, and this is what these policies are proposing. So in the next minutes with the others, we would discuss also maybe some solutions and what comes out of them. So I wouldn't take more time on this, but
okay,
let's discuss later.
Thank you very much, Theodore. I think it's indeed a good way to set the scene, and just to we will come back on the proposed solutions or the action which are needed in the second part. So now I would like to ask Nicolas. So Nicolas Delianakis, sorry Nicolas, who is a policy coordinator at DG RTD in the Prosperity Directorate. So your role is really to coordinate the industrial aspect in Horizon Europe work program. You are developing also the part on advanced manufacturing, which is closely connected with advanced materials. So we heard a lot about the announcement by the Commission of the proposal to elaborate a coordinated plan with member states on advanced materials. Can you tell us a little bit more about this plan? What is really the ambition that the Commission has there?
Yes, thank you, Philip. First, I must come clean, because I'm not an advanced materials expert. When I was a physicist, I used to work on nuclear fusion, and there the only good material is a fully ionized one. But anyway, today I will indeed say a few words about the coordinated action plan. So the scene is that advanced materials are an engine of innovation, but the EU now has only 15% or so of the relevant patents in advanced materials. So that is our problem and our opportunity. You may have heard the President of the Commission who said that advanced materials are crucial for industrial leadership in her State of the Union speech in September. And you also heard from my colleague that advanced materials are embedded in many ways in policy, the Critical Raw Materials Act, the Net Zero Industry Act, and also the Strategy for Economic Security. Now in Horizon Europe, as in previous framework programs, we have quite a lot of support for advanced materials. In Horizon Europe, if I were to look at advanced materials, at 2D materials like graphene, which has so far been a bit separate for various reasons, and also what we call safe and sustainable by design, chemicals and materials, all that comes to almost 200 million a year, very roughly. But this is not the whole story, of course. There are more investments in Europe, but in any case, it is not enough, given the enormity of the task. Hence, our proposal to have a so-called coordinated plan of coordinated action plan with the member states in Europe on advanced materials, or rather more generally innovative materials, including graphene and 2D materials. So this is to build on existing initiatives, of which there are quite a few, like the ERANETs. I don't have enough time for details, but there are already networks that we call ERANETs. And there, of course, we have had the graphene flagship and so on. So the idea is to build on those initiatives and, of course, the excellent work by EMIRI and others in the Advanced Materials Initiative 2030 to create an ecosystem that is for advanced materials or innovative materials that is strong and can secure further investments. Now, again, there is a lot of detail in that, but some of the key elements that we want to address in the coordinated plan is to, of course, provide a leadership for the next generation of innovative materials. That one is obvious. Then to work on the uptake, and already we have had initiatives like the so-called open innovation test beds that we funded in Horizon 2020. So again, we want to build on those. They're in some ways analogous to the digital innovation hubs, where SMEs that want to innovate with materials can find support as well as technical know-how. We want to connect materials to circularity and to sustainability. That, of course, goes almost without saying. And, of course, when it comes to critical raw materials, circularity is as important as sourcing the materials. So if we can recycle the materials, that solves part of the problem. And of course, another way of solving part of the problem is through substitution of critical raw materials. So that is also addressed in the coordinated plan. Then we want to support the digitalization, digital discovery of new materials, without which you cannot do that much. It accelerates, I'm told, the innovation process enormously. If you can quickly eliminate the dead ends, for example. And finally, we want to align the strategies, different strategies of the different member states in the EU on materials and engage with industry stakeholders. Now, to do all that, apart from the coordinated plan, which we hope will be adopted next year, we have proposed in the Commission a so-called co-programmed partnership. A co-programmed partnership is where the industry, the Commission works with industry to develop priorities, to develop topics, and of course other stakeholders, not only industry. And in return, industry undertakes to make further investments. So one example of that is the Made in Europe Partnership for Manufacturing, on which I work. So that is our proposal. It is only a proposal, which we are now discussing with all the players. There are counter proposals, but anyway, this is the Commission's proposal to have a co-program partnership to support the coordinated plan. And with that, I can
Thank you very much, Nicolas. And I think that's a very good transition now with the next speaker, which is Christophe Morisseau. Christophe, you are Senior Vice President for Advanced Research at Michelin. I guess nobody needs to be introduced to Michelin. Everybody knows what Michelin has been doing for more than 1 century now. But I know also that Michelin is really looking to develop and to grow also by building on other materials. So can you really elaborate a little bit more on what is your strategy on materials and how this strategy is connected with the sustainability dimension that was mentioned by Nicolas?
Yes, thank you. So just I can make a small testimony on, you were citing as an introduction the question of our sourcing questions, and due to we normally have around between 5 and 10 crisis sales due to sourcing every year, and with COVID and then with the Ukrainian situation, then we got more than 100 crisis sales open at the same time everywhere in order to cope for how can we change the sourcing in a very urgent and efficient manner. So it's really a strong disruption that we have been living through. So it really raises this question of having a more diverse sourcing, not depending on one country or one place, and be able to depend. Just for those who are not familiar, a tire is composed of more than 200 different materials. We have steel, we have textiles, we have polymers, we have specialty chemicals. And in the past years, most of these have been moving to places outside of Europe and creating also some dependency. So just want to, again, insist that, of course, you've been insisting on the fact that we need to go for critical materials for new economy along with Net Zero Act, but it's also important that we think about critical materials for existing economy. And in particular, there is all the chemical supply chain that has been slowing down in Europe for many years now. And thanks to the new paradigm with moving to different sourcing, for instance, Michelin has been taking a strong commitment to, in the coming 30 years, so by 2050, completely exit from fossil or extract sourcing and go to only recycled or biosourced materials, which is an enormous challenge, but it's also a very good opportunity for moving to new and advanced material and rethink about new sourcing and maybe recreate in Europe new supply chains and sourcing for all this industry, because of course it's not only Michelin, the full tire industry is also committed in this direction and other industry also. So that's very important for us, and in that frame, the Advanced Material Program is a very nice opportunity to really reinvent new materials, new way of doing tires. And as you've been saying, it's also a strong strategy at the moment for Michelin to say a tire is mostly made of very difficult and advanced materials. And so this know-how and knowledge can be useful for something else than making tires. And Michelin has been engaged for a few years now in really trying to see how much application of these materials can be applied to other areas. We are, for instance, very much engaged in the hydrogen economy, first through GV for fuel cell fabrication, but also trying to provide new polymers and materials that can be part of the hydrogen electrolyzers or fuel cells. We're also working, for instance, for some packaging with specific properties for batteries and everything, specific composite tissues that could be helpful for wind. So we're trying really to say all this know-how on complex products, complex materials can be applied in very different areas. So it's very challenging, but also very nice opportunity. and it's going to increase, again, our dependency on very different sourcing of materials. So we very much welcome this initiative of helping at industry scale with all the suppliers, SMEs, together to move to a new economy, beginning with some research and then scaling up fast in order to solve the critical challenge we have.
Thank you, Christophe. So now, giving the floor to a research center, Dr. Oscar Miguel Crespo, we know quite well because we have been building together this battery partnership. So Oscar, you are working as Deputy Director at CIDETEC Energy Storage Institute in San Sebastian. You have been involved in energy-related industrial research activities for more than 20 years now, mainly in batteries and hydrogen also. And recently you launched a first spin-off, which is another adventure. So I really would like to also hear from your side what is really the benefit of such a coordinated plan on advanced materials, how this can really address the challenges which are tackled in the Critical Raw Materials Act and the Net Zero Industry Act, and also what you feel about setting up a new partnership on advanced materials. Thank you.
Thank you very much, Philippe. Can you hear me?
No,
No? Because I can't hear myself.
we cannot hear.
Hello? Good?
No?
I can speak louder, but maybe it's not. No, it's okay. Okay, thank you. So, Philippe, thank you very much for your kind introduction and your invitation to be here today. It's a real pleasure. Yeah, I think here I'm somehow representing the batteries area, which is, I mean, quite a lot in the news, and there's a lot of expectation around this area because it's one of the key facilitating technologies for the energy transition. At the same time, is very highly consumer of critical raw materials. We all know very well the issues with lithium, cobalt, graphite, and many others. And yeah, and at the same time, it's a very complex product that you need to have very well optimized. I mean, I like to think of this cell, I mean, it's not my invention, that a lithium-ion battery cell or battery is like flipping a coin into the air and hoping it comes to the edge. So if every single parameter in the materials composition and manufacturing is very well tuned, the battery will work. So it's very, very dependent on all this. At the same time, as I said, today, for the time being, is very much taking materials that are not available in Europe, both as the source and both as the processing of these materials. This is a weakness for the time being in Europe. And and my other argument is that in our experience, every time a new material comes for the battery sector, we are not involved in how to synthesize these materials, how to produce them, but we are involved in how to put these materials into a working battery. And every time a single improvement is done on any material, you need to optimize again the electrode formulation and the recipe of the electrolyte, etc. You need to optimize how to produce and to manufacture all these electrodes and the cell itself. So it's not only about finding the right sustainable and by design materials. It's not only about how to synthesize in them, but it's also to take into account into this whole process how these materials are put into the real application, especially in this kind of very highly demanding applications like the area of batteries. In this regard, I hope hopefully the good news that we will have a materials partnership thinking holistically in all these parameters will help and will assist in going further with all this stuff. And I want to finish by mentioning the other big board that I think is very much related to what we are discussing here today, which is digitalization. Because, as I said, I mean, you need to find the right materials, you need to manufacture these materials, you need to fine-tune the manufacturing of the products, including these materials. This is a very high consumer of trial and error, person workforce, etc. So digitalization will need to help in shortening the efforts we put in this whole process, and I'm sure we will talk about that later on.
Thank you, Oscar. So now, last but not least, in our panelist, a young entrepreneur, Mariam Kadran, which is the founder and managing director of Planck Technologies, which is an SME based in Norway, which is delivering optimal material design for energy storage application. So you are totally on your domain here, and really what I would like to hear from you is more what you expect an SME in that field, really what you expect from the public initiative like the partnership that we try to set up now with the Commission.
Is it working? Yeah. So thank you very much for the introduction, and I just wanted to say also kudos to you to assemble this panel. It's diverse, from industry of a century old to a startup of 1 year old, and research centers and also policymakers. It's a really good fit that we all talk together. And then like a few minutes on introducing our startup. We are working on optimizing the current and discovering the next generation materials for energy storage applications. I have a background from industry. Of course, like I was in academia doing a PhD, and then 10 years of experience in industry, and then I'm from the problem side. I have seen the need, and that's the motivation that I started this startup. And kind of addressing this from the digital point of view, how to kind of come up with the new materials which can kind of have the answer to the needs for the energy sector, being linked to the renewable energy. And then, like, we see our link to both of the acts that were named here. We are focusing on energy storage, on batteries, and also on hydrogen, which are some of the technologies mentioned in net zero. And also, our aim is to try to reduce the dependency to critical materials. So we are we're working on a screening tool to kind of screen the materials, focusing on how to optimize the current solutions and kind of come up with a next generation. And then we can put different filters on it. Since I'm not a chemist, so we are not focusing like only on the performance on the chemistry level, but focusing on sustainability aspects, kind of screening through the materials which are like non-rare earth and like many items which don't tick the sustainability criteria, and also focusing on like how these materials would perform in the process. So early on, we are planning to collaborate with research centers like you to kind of make this more meaningful and closer to the market. So when we started this, so we know that like the VC area is not like very ready for this type of technologies yet, because it's like in deep tech. We are not a manufacturing company, but still, because of the mix of different expertise that we need to develop this product, and also the computational effort that we need and all that. So we are not like as cheap to invest as a SaaS solution. Actually, we were suggested to can we make this a SaaS, which is not quite interesting business model for us. But then we understood that because of all these initiatives and the support from the EU, it could be a nice path for us to go to this area. I just want to make an example of some of the things that we have done and like the challenges that we have seen so far. Like, we have been part of a consortium for an EU project, Innovation Action. So I think it's a very good fit for startups to be part of that, because it's closer to commercialization. And then starting from April to the deadline of September, working very intensively to reach the deadline and submit the proposal. And then afterwards, it's like fingers crossed, if this gets through or not. It's like, I would suggest maybe a simpler process for having startups involved in this kind of innovation actions, which are related to advanced materials and to clean tech, which is actually the ambition of EU to be #1 in that front. Then, I have some other points that maybe I can go to later.
Yeah, thank you very much, Mariam. Yeah, and before we move to the to really the more the open discussion, I would like also to emphasize that the vision we have in AMI for the new partnership, I think, is very much aligned with what you have been talking so far. So definitively, what we want to do or what we would like this partnership to do is to cover the entire value chain for materials, from the design of advanced materials. So we leave the critical raw materials mining, sourcing, or refining to others, and we start starting working on the design of the advanced material, the processed materials, and we want to cover all the steps in the value chain, the production of these materials, of course, the processing, transformation, integration into the products, the behavior and following the materials during the use phase of the product, really to understand how the materials are aging and are behaving, and also at the end of use of the product, when the product is not working anymore, really to manage the end of use by all the different strategies which are possible from repair to recycling, and really so that to be able to close the loop. So that's the first, let's say, ambition, which is to cover all the different segments, which means that we will have to collaborate a lot with existing initiatives. You were mentioning Made in Europe. That's definitively a partner in really addressing this ambition. We want to mainly to rely on three main levers really to address all these different segments, which is digitalization and data management that was mentioned, all the tools on, well, modeling, characterization, testing, how to improve also all these technologies that can really help also understand better how the materials are really behaving, and really the fundamental science behind the materials. And of course, we want to act as a facilitator or to help the regulators really to implement the policies and the frameworks. We were talking about system sustainable by design, so you know there is this initiative at the European Commission level really which is recommending really to follow this approach, and that's definitively something that we would like also the partnership to support and to facilitate by providing the appropriate tools which maybe are still missing. There are still some issues gathering the data which is needed really to assess the different criteria and so on and so on. And this, of course, we want to do it in a very holistic approach. So bringing all the different relevant communities together. So I mentioned the different segments along the value chain, but we need also to bring together the academic research on fundamental aspect with the industry and the market needs from the different sectors. So that's definitively also one of the big dimensions that we would like to be covered. You were mentioning, Nicolas, the technology infrastructures with this open innovation testbed. That's definitely something that we would like indeed to support and to be again implemented and deployed under this initiative. We have identified 5 specific objectives. One is embracing cutting-edge functionality. So that's also developing new materials, feeding the pipe with new, innovative and advanced materials. That's reducing, substituting critical raw materials, and really for achieving more resilience. It's about saving resources, so better using resources, resource efficiency. Still a lot of progress which is possible by improving really the materials performances. And then favoring also renewable resources, so getting away and contributing to being less dependent from fossil feedstock, really by favoring the development of advanced materials which will be based on renewable sources. And last but not least, contributing to the enabling the circular economy. So building recyclable materials, but also making sure that this is consistently aligned with an eco-design of the products and which make them easily recyclable. So that's really the ambition we have for this co-program partnership, which is named Innovative Materials for EU in the proposal that were released by the Commission in July. So we are now currently working closely with different stakeholders and with, of course, with the Commission services, really to shape the proposal that, as you mentioned, is still to be decided and validated by and with the member states, of course. So now I would like to come back to the more the discussion part, and we were talking about technology sovereignty, and I think that's definitively, well, that my reading of the priority that has been announced by President van der Leyen for mentioning advanced materials for industrial leadership. And so my question to you is really, what are really the actions which are required to be able to compete with the other regions of the world that are also very attractive? We can mention the IRA in the States and the policy of China. So what are really the actions that really will allow to reinforce EU industrial and innovation leadership, innovative leadership? So I don't know who wants to come first.
Can I talk on behalf of startups? So yeah, we mentioned about like the like proper path for startups to help with these initiatives. Is that like, yeah, we are between the universities and commercialization, and we are the muscles to help to achieve this. So I think that we need more support around that. Like, we are new in this field, but we have seen a lot of complexity, which can make things difficult. A lot of consultancy services maybe you have seen in this area, which kind of shows the complex area that we're in. And kind of easing it up for startups when it comes to innovation actions, when it comes to like the EIC initiatives and the type of initiatives which we need action, we need to kind of implement things and not doing the ground-based research.
Thank you. Christophe?
Yes. I would take it reverse, saying, okay, what makes China and the US so successful? And so, to make it very simple, China is successful because they are very long-term and they provide a lot of stability in the vision and the way they think on multi-decennial directions. And on the other hand, US are very pragmatic. And so, in many cases, I think that in terms of pure innovation, Europe is quite well placed for inventing things. One of the big difficulties that come to place is when it comes to scale-up and deployment. You've been citing, and it was also a lot of discussion in different panels, with different applications on different countries of a global directive that comes to force. We're discussing about recycling, for instance, and we know that just moving materials like old batteries, old tires, or old things from one country to the other, if they are considered waste, you cannot move them, it's very difficult. So there's a whole lot of context in terms of regulation. So it's important that, as we do here, we create a context to innovate and invent new kind of materials, but it's also important that the next stage, which is to scale up, to be consistent in the long term, and to create the necessary rules with a quite stable and very standardized way in all Europe, is something very important for a large-scale impact, which is often the place where we're not good enough, and then we leave the floor to our other colleagues from the other continents.
Yes.
Another element we heard about in one of the plenary sessions, and that is to inspire people to work on, in this case, materials. Of course, it doesn't apply only to materials. So education and skills are very important, and to that end, we are proposing, amongst other things, a materials academy with the EIT. But more broadly, one needs to inspire people to work in science and research.
Yes, Theodor.
Maybe I can add a bit more. So it's very good to hear some of these things, but also I can mention that so the EU is leader in patents for some of these technologies. So we are very good at innovating and very good at creating a product, but we are kind of failing to bridge the gap between the patent and the lab work and the commercialization. So when it comes to some of these technologies that are mentioned in the acts, even just 15 or less years ago, the EU was a leader in solar PV, or at least one of the leading developers and so on. But now, over 90% of the whole supply chain is China. Everything comes from there. So they managed to scale up and to advance, not with groundbreaking technology or something that we don't know about, because we had that. We knew about these things. But something that we should learn from, and this is something that Maria mentioned, is that when we have the startups, they need the needed support. So this is something also good to hear, that these policies are not shooting in the dark, so it's a bit on the right path. So there's a proposal for regulatory test beds. So there's also sandboxes. So these companies would be allowed, like, let's say, not looser measures, but they would be allowed to innovate and to do their research and to propose new solutions. But then also it comes to funding. So we have just amount of EU funds, so we can reshuffle them as much as we want, but that's about it. So there's also a need from like public-private funding or also national funding. So it's a mix of everything to make a project or a sector successful. As you've heard about the batteries, this is one of the examples that we give, that a few years ago it was not so well developed. It was, let's say, germinating. It was starting to grow, but now it's a full-fledged ecosystem that some people don't even know how many actors are in it. So there are ways forward.
Yeah, if I can comment. Can you hear me now?
Yeah, okay. It's okay.
Yeah, I mean, my comment is not battery specific, but it's more generic. But we were, having an interesting discussion. We are somehow complaining that Europe is good for inventing things. Europe is also a good place for engineering. We have very strong automotive engineering companies, etc., etc. We are a big market. We are not having so many natural resources. And what we are missing is the manufacturing capabilities. Because for many, or at least the recent decades, we have been sending such manufacturing capabilities somewhere else. Sometimes for the not in my backyard principle, because we don't want to have dirty manufacturing companies behind our cities, and sometimes, probably most often, because it's cheaper to do something in other countries. And the result is that today we have a weakness. And we say, okay, we have patents, we have invention capability, and we don't have the means to implement locally these inventions. Sometimes because we don't have the manufacturing capability where to implement these innovations. So I hope the Net Zero Industry Act is helping to take back at least the key manufacturing strengths in order to achieve what we are aiming for.
Coordinated policies on the industrial, R&I, regulatory. I think that we all know that's part of the recipe for success. Indeed, batteries is a good example of what was done. I would like to come back to one topic that was mentioned by a few of you about digitalization. Really, I think that, well, we all know that we are really in this race, and it's really, we need to find ways to accelerate really the development of new technologies. So I really would like to come on the question whether digitalization can help, and how digitalization can help. What is the potential of artificial intelligence and all the digital tools really to accelerate the materials development and uptake. And before I give you the floor, I would like to remind to the audience that we are still connected on Slido, so don't hesitate to put your question in Slido. We will take them in a few minutes. Okay, so coming back on my question, digitalization. a potential to speed up and to accelerate really the development of materials. And also, I think it's not only the development of materials, but it's also how digitization can help on the product passport, materials passport. I think there is also in the Foresight study, there was some hints about to have a better knowledge of where the materials stand in the different value chains and so on. Mariam?
Yeah. So I mentioned one time that we're working on material screening, and so this cannot be done with experimentation with trial and error. A database of materials that we are connected to has 1 million materials, different structures, and then we're screening through that to kind of find out which properties of materials are fit for the application that we think about. And if it's think it without AI, then we should focus on computational chemistry. And still, with the biggest servers, it's very time-consuming to do that. So a mix of computational chemistry and AI can make things possible which were not possible to even think about before.
Yeah, maybe I can add on top of that. Yeah, I mean, in the batteries area, we are lucky to have an initiative called Battery 2030 Plus. Maybe it's already known for some of you in the audience. And Battery 2030 Plus is a long-term initiative aiming to develop the batteries of the future, but not because we are somehow choosing the right path to follow in terms of this is the battery technologies of the future, but to develop the tools that can help us to reach whatever battery technology comes later on. And in this regard, digitalization is one of the big areas of development, because and we have the Big Map project leading this effort. And the aim is to develop the digitalization tools in order to find the best materials for a specific battery application, how to manufacture systematically by help of the IA tools, how to test these materials, and only after this, let's say, digitalization path has been followed, you can do some limited experimental tests to validate, and this is, I mean, kind of the ideal way to follow. Because it's not only the computational chemistry to develop the single material, but also the next step in how these materials think in particles, solid particles, how can you combine in order to get the best product, in this case, the best battery, also saving the effort of the trial and error of trying different ways to combine these materials. So it's several levels where digitalization is helping in this regard.
Yes, and what's important that when we speak about advanced materials, new application, it often goes to more complex materials. And I think that we can dream of these materials because the new simulation, digitalization that we have allowed to think differently, to go deeper, to better understand the results of the experiment. So it's not replacing, as you said, all the experiments and characterization, but it's helping to better understand where to go, where to look for, and there's still a whole lot to go. The interesting point is that when we discuss advanced materials, the state of the art of the existing tools applies to existing materials. So when you want to invent new materials, you have to develop the new simulation, digitalizations along. So it's important that in this IMI, there's also a large part dedicated not only at using these kind of tools, but also developing the tools for the future for more complex, multi-scale, multi-components materials that you cannot manage if you don't have the full set of measurements and simulation.
Quickly, a last question before we jump to the question from the audience from my side. The innovation ecosystem, I think that's definitely something that we want to reinforce in AMI 2030. And so I really would like to get also your opinion, maybe more those who are directly active in research. So from big companies, how you practicing open innovation, and also from research centers and startups. How do you see this open innovation framework?
From the big company point of view, I think many big companies, and Michelin of course is using a lot of open innovation. It's been, the set of tools for open innovation has been getting larger and larger. Historically, there was work with suppliers on one side and universities on the other side. But more and more, There are discussions on creating large ecosystems with both SMEs, startups, other big companies that can be non-competitive and sometimes competitive, because what we aim at here is so big that nobody can pretend to do it alone. So really have to partner with public, private, big, small companies all together if we want to tackle the big challenges that we have had. And the good news is that the tools to do so have been developing a lot in the past years, the culture, and I think most big companies, and for sure Michelin, are now ready to take these challenges, and we have all the tools in place. So.
Very good point. Actually, I will just repeat what you said, that no one can do this alone. So partnerships should be in place, and our approach is to start early on engaging the possible customers and the stakeholders and solve the problems together with them. Yeah.
Quickly, one comment from your side, Oscar?
Yeah, in this effort, we have used one word several times so far, holistically. So in this holistic development, I hope industry is part of it, because as I said, I think in my first statement, it's very important that the end users of these new materials are involved since the beginning, because maybe the kind of products or processes in which these new materials needs to be integrated, it's something tricky and deserves attention. So I hope, and in the batteries sector that I'm involved at, this is true because we see several companies, but it's also true that we have the effect of the usual suspect. There are several companies very relevant in the sector that are involved, but there are other companies also relevant, but they tend to not get involved also in this kind of discussion. So I hope we can enlarge the circle encompassing all these relevant companies in this effort.
Thank you. I really would like now to move to the questions we got in Slido, and there is this one that I highlighted here, which I think is very, very relevant. How to make sure that we will also anticipate and make sure that the solution that we will be developing will be safe and sustainable. So it's about this safe and sustainable by design framework that has been recommended now by the Commission. So indeed, developing ever more complex advanced materials requires a lot of trade-offs. So how really to make sure that we will make the good choices, I think that's a very, very relevant question. Nicolas?
Please go ahead.
Well, the whole idea, of course, is not to balance, but to incorporate it by design. So hence all our guidelines and the research we fund. And of course, historically, a lot of our problems have come from materials where safety was not built in, and then became an afterthought. An extension of that in manufacturing is that we also, just like safe and sustainable materials by design, we want to make sustainable products by design, products that can be more easily disassembled, both in order to reduce waste, but also in order to be able to recover raw materials. So yes, all these things, we try to integrate that rather than balance it.
Another question, so let me highlight it. So another question that maybe I can take myself, how can the industry representative join the partners of the co-program initiative on advanced materials to contribute to the writing and the design of the future calls? Well, we are not yet at a stage where we can start driving or writing the calls, but you are more than welcome really to join the initiative. We have a dedicated website, AMI, so AMI 2030.eu. You can join. There is a form to join the initiative, and then you will be invited really to the upcoming workshop that really will be organized really to define really the skeleton first of the SRIA, and then really to enrich this one by really the more details on the different priorities that we would like to be covered in this partnership. The next question. I'm afraid I made a mistake in. I don't know why. There was another question that I cannot see anymore. Let me, I think in this one. Yes. The development of new materials requires research on how to proceed with them, how to process them, machining, joining, recycling, etc. How does the EC, and I think more globally the community, see this being addressed? So I think that's definitively part of the ambition that I was mentioning, that really we want to not only to develop materials per se, but we want really also to integrate the processing and integration aspect. I don't know if you have some opinion, some remarks to provide on this topic.
Maybe I can give some more information on that. When it comes to some of the processing steps of the supply chain, for many of the technologies that we studied, the EU is not as bad as in the first steps when it comes to the sourcing of the materials. So we do have some expertise in processing, and we do have some expertise in recycling. Of course, for the recycling, for many of these technologies, it also comes down to money and how, whether that process is sustainable in terms of financing and so on. Because some of these, even though we have the knowledge how to do it, it doesn't mean that we can do it at scale. So, which comes again to the previous discussion that we had about the scaling of this thing. But when it comes to the processing at large in the EU, for many of these steps, this is part of the legislation. This is part of the proposal. This is what we try to to promote and to see what would happen now with the discussions with the Parliament and the Council. But usually, these should be ingrained in all the future developments that we have. So far, it's proposed to have this as the policy, but let's see for the next steps.
Thank you. I'm struggling with Slido to try to get the next question. Sorry for that. So it's maybe more a comment than a question, but I think it's interesting. One of the challenges is to reproduce at the lab the failure mechanism of the application and transfer lab-scale testing results to the application. Is it something that speaks to you?
Yeah. I think most industries are confronted to that problem, that you can do beautiful things at the lab scale, and we discussed the scale up on manufacturing side to make it competitive and at the larger scale, but also going to the real world and actual, you always have a long way to validate the robustness in all the conditions of real use of batteries and any object or products. And so that's really a key issue to master anticipation of the robustness and accepting that it takes a long time to validate sometimes.
Okay, I think with that we are out of time, so I think that we need to close now. So I would like to thank you all, the panelists first, of course, but also all the people who attended the session, both on site and online. And so if you are interested to join AMI 2030, you can see the link here on Slido. So don't hesitate to join us. It's still time. We are just in the middle, really, of the work to shape this new partnership on advanced materials. Thank you very much, all of you.